Let us study about voltage ampere characteristics or VI characteristics of PN junction diode. This can be studied in two different ways. Firstly, forward bias condition. Secondly, reverse bias condition. Now, let us study about forward bias condition of PN junction diode. Figure here shows the PN junction diode connected in forward bias condition, which means P-type, that is the anode of PN junction diode, is connected to positive terminal, and N-type, that is the cathode, is connected to negative terminal of the supply. When the switch is on, the potential barrier of diode is reduced at some forward voltage, that is when it exceeds 0.7 volts for silicon and 0.3 volts for germanium semiconductors. The potential barrier is completely eliminated and current rises sharply as shown in VI characteristics of PN junction diode. In this characteristics, the x-axis represents forward voltage and y-axis represents forward current. The forward voltage at which current through the junction starts to increase rapidly is known as knee voltage. Once the external voltage exceeds the barrier potential, the PN junction breaks down and it behaves like an ordinary conductor. Therefore, the current rises sharply with increase in external voltage, causing the characteristics to be linear. Points to be remembered in forward bias characteristics of PN junction diode. The depletion layer decreases when PN junction is forward biased. At some external voltage, potential barrier is completely eliminated. The diode conducts when external voltage applied exceeds 0.7 volts for silicon and 0.3 volts for germanium. The junction offers very low resistance when it is forward biased and causes current to flow. Current flows in the circuit through majority carriers. Current measured in forward bias of PN junction is in the order of milliamperes. Secondly, let us understand about reverse bias condition of PN junction diode along with its VI characteristics, that is voltage ampere characteristics. In this figure, the anode, that is positive terminal of diode, is connected to the negative terminal of power supply, and cathode, that is negative terminal of diode, is connected to positive terminal of power supply. When the switch is on, the conventional current flows towards the PN junction diode, increasing its potential barrier as the diode is reverse biased. Therefore, the junction resistance increases, causing small current to flow in the circuit, that is 50 microamperes for germanium and 20 microamps for silicon. This current is called reverse saturation current. If the reverse voltage is increased continuously, breakdown occurs at junction, causing sudden fall of resistance, which results in sharp rise in reverse saturation current. The minimum reverse voltage at which PN junction breaks down with sudden rise in reverse current is known as breakdown or avalanche region. Points to be remembered in reverse bias characteristics of PN junction diode. The depletion layer increases when PN junction is reverse biased. At some reverse voltage, potential barrier is increased. The junction offers high resistance in reverse bias condition, causing small current to flow, that is 50 microamperes for germanium and 20 microamperes for silicon. Current flows in the circuit through minority carriers. Current measured in reverse bias of PN junction is in the order of microamperes.